Welcome to final exam, question number 3. And it gives us a reinforced concrete beam with B equal to 14, D equal to 30. It says it is subject to an ultimate moment. So that should say, hey, ultimate moment. That should set this off in your head that MU equals 400 foot kips. So that's your load. And it's factored, that's everything. And this needs to be less than or equal to, I guess, phi mn. And we know that phi mn equals phi as Fy d minus a over 2. Random blank there for a second. And sometimes if you want to go ahead and do this, 1/12, that just is the automatic conversion from foot to inches, because this is in foot, this will be typically in foot, and you want to get to inches. I mean, you want to get to foot. I'm sorry. So I hope that makes sense. We're in inches because AS is going to be in inches, FY is going to be in KSI, we'll square inches, and then we'll go from inches to foot, and that's how you do it. All right, so I guess we can just go ahead and start solving. It says that, what, D equals 30, which we need D. We also need, what, AS, let's write AS over here. FY is going to, 99,000% of the time, it's going to be 60 KSI. And then phi is always going to be 0.9 for concrete. And bending, this is bending. And then dA, we need A. And it said that A, assume A to equal 0.2 D. D, which equals 0.2 times 30 inches, which 0.2 times 30 equals 6. That's a pretty big D. It says, and use the table on page 87. I'm not sure what that table is. I'm assuming it's reinforcing table. It shows you what the area of reinforcing is. I have a little card that tells me this. So I always look at the little card that's on my desk. It's a laminated thing. And let's look on page 87 and see what they give us. Hopefully it'll be the area of steels, because that's what we need. We need to figure out what the area of steels are. And yes, that's what it is. Alright, so what I would do in this circumstance is just plug and chug. I would assume, let's write the area of steels for each, actually. I'm going to set up a small little graph. Control Z. No, that's ain't it. What I want to do is get rid of this AS floating. Alright. So, that's our given. And we have a few choices. We have A, B, C, and let's move down and I'll get you D. And we have 3 number 8s, 3 number 9s, 2 number 11s, or 3 number 10s. So let's make a real quick graph. I would look at this and see right away, you say, okay, I have everything I need. Now I just need to plug in the AS. This is the one thing you don't need, you don't have. And that's what it's asking for. So we go in and say, okay, well, what's the area of steel for each of these? It looks like they're going in increasing order. And while I'm writing this, I'll tell you what I would be thinking. In my head, I'd be like, well, we know that the probably biggest is going to work no matter what. So let's go to one of these middle two, which I'll start on this one and go down, work my way down. So assume this one will work no matter what. If this doesn't work, then you automatically have that one works. So I would start with C. But let's just go ahead and do all of them real quick. 3 number 8s. So it's going to be 3 times the area of steel of a number 8 bar. The 0.79. And then 3 times number 9. Number 9s are 1.00. I'll get my calculator out in a second. It's going to be 3 times number 11, which is 1.56 inches squared. And then number 10s are 1.27. Alright, so this is the unknown for each of our options here. And let's go ahead and solve for them. 3 times 0.79 equals 2.37. And then we have 3 times 1 equals 3.00. 2 times 1.56 is what? 3.12, I believe. Let's do that on my calculator so I don't screw stuff up. 3.12, I was right. 3 times is what? 7.2, 7.1. Let me do it on my calculator. 3.81. Good thing I didn't do that in my head. Alright, so those are our options. So all you could do is, what you could do is set up phi mn equals phi mn equals, whoops, phi mn equals and phi mn equals. So you set up a graph. Or not graph, more of a chart. And you remember, you could do all this stuff in your head if you wanted to, or you could do it all on your calculator. You wouldn't have to write all this stuff out. I know it's a little time intensive the way I'm going about this, but in your head, I'll go over at the end of each problem, hopefully how to do this a little bit faster, and how I would do it in my head. Alright, so once again, I said I'd start right here with the 2 number 11s. So let's go ahead and type that in. And well, what the heck. Let's write it out. Once again, I would not write this out. 3.12. I'm going to not include the units just because I'm running out of space here. Actually, I'm still not going to include my units just because I don't want to. Alright. And then where is this? Phi AS FY is always going to be 60 KSI. D is going to be 30 inches minus A, which we said is 6 inches, 2. And that's going to be all divided by 12 to get to 2 inches. 0.9 times 3.12 times 60 times 30 minus 6 divided by 2 divided by 12. 379.1. And that's in foot kips. When I said get to inches, I meant to get to foot. Get to foot kips. Because if you didn't do that, it'd be inch kips, which I typically don't like working in inch kips. I like working in foot kips. Alright, so what did we need? We needed 400. So it doesn't look like that one's going to work. So there you go. Right now you should know, hey, that one's not good enough. This is less than our load. Our capacity is less than our load, and therefore you could just figure out D. But let's go ahead and solve for D just to make sure, because we like to be thorough. 3.81. And remember, this A right here is dependent. This A is, what is it? AS FY 0.85 F prime CB. So this is typically going to be 4,000. You know what your B is because they gave it to us. Our 0.85 is always going to be 0.85. So it actually is going to depend on that. But they said, hey, assume, for simplicity, assume every single one of these is 6. But it will change. And actually, let's see what it is real quick after we get this done for the right answer. 60. 30 minus 6 over 2. And then 112. And we get 0.9. Once again, I would do all this on my calculator. I would not do this. Hopefully you can get to a point where you are familiar with this equation where it's just second nature. And this gives me 462.9 foot kips. And that is more than we need, and therefore that is going to be our correct answer. Is D. Alright, so let's do another quick exercise, and let's figure out what the actual A is. You can call A ACT for actual. AS we know is 3.81. And that's going to be inches squared. 60 KSI over 0.85. 4 KSI. We're assuming we have 4 KSI steel, or concrete, sorry. And then our B, what did it say it was? Which is 14 inches, which we never actually used because we didn't need it. Because this equation is all based on the tension side as opposed to the compression. 3.81 times 60 divided by 0.85 divided by 4 divided by 14. And we get 4.8. So as you can see, our actual is a little bit different. And let's go ahead and throw it back in here and see what we get just for fun. Because it is fun. You're having fun. 4.8 inches. So we'd actually come up with, I'm not going to write it out, 9.9 times 3.81 times 60 times open parentheses 30 minus 4.8 divided by 2 divided by 12, close parentheses, and then divide by 12, sorry. 473. And when you see, if you actually, this should tell you one thing. If you assume a larger A than what is actual, that you're going to be on the conservative side. All right. So your answer for question number 3 is D. All right. I will see you on question number 4.